Hello out there. Thank you for staying tuned. I am Canis Andutan, and we shall be building up weights for different grade of concrete. And let me quickly run us through the different grade of concrete and its cement uh, content. We have uh, uh, ratio of 1 is to 4 is to 8 with the 170 kg uh, cement content. We have ratio of 1 is to 3 is to 6 with the 200 cement content. We have the ratio of 1 is to 2 is to 4. We have the 305 kg cement content. We have a ratio of 1 is to 2 is to 3.5. We have a 320, a 320, a 340 kg. Then we have the ratio of uh, we have the ratio of 1 is to 2 is to 3, which is a 370 kg, 370 kg cement ratio. And as the cement differ, so also the quantum of sand and granite also differ. So let us quickly go to the calculation proper on how we arrive at the content of cement, sand, and granite. As you can see, like the first one is the ratio of 1 is to 4 is to 8. And if you add the part of sand, the part of cement, the part of granite, the total will be 13 parts. And 13 parts is what makes up the ratio of the quantum of materials that you use uh, to to mix this grade of concrete. And bear it in mind, the rate we are building is for a 1 cubic meter of concrete. A 1 cubic meter of concrete in its weight state is different from a 1 cubic meter in a dry state. Why is it different? Because those materials, they are dry. As soon as you put water into it, it shrinks. It shrinks. When it is dry, it bulks. And when it is wet, it shrinks. So now for you to calculate the the percentage of the shrinkage or the bulking during a dry stage, you have to factor in the the wastes, say stack waste, say movement waste. Say when you are transporting the material from a particular place where you have stacked it to where you want to mix it, some would drop off from the whatever transportation system you are using. Either it's a wheelbarrow, it's a headpan, or it is a pail, or definitely there are some uh, uh, quantum of waste that will attract. And the shrinkage, the shrinkage or the bulking for sand is 30 to 33, 34%. And why the 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 waste, stack waste, stack waste, transportation waste is around 20%. So that is what you see. I computed in this place, and it came to about 54. So the 54% will be added to the weight, to the weight volume, for you to now have the quantum of material that we use in the dry stage when you want to mix the wet concrete. So say I need material more than a 1 cubic in a dry state to mix a 1 cubic in a wet state. That is what this is trying to tell us. So haven't gotten your cubic, your material, your dry volume, which is now 1.4, 1.54, because you have a 1 here plus 50, plus 0.5 plus 54 gives you 1.54. Then now we'll now go to the individual material. We'll start with the cement. In this ratio, we're having 1 part of it as cement out of the 13 part. So for us to get the percentage of the volume of the 1 part, we have to divide it by, we divide the 1 part by 13 to give us the part of cement in the 13 part. Then the density of cement is 1440 kg. So if you multiply the dry volume and the part for cement and the density, it will give you a 170 kg. And the 170 kg, what does it translate in bag? You just needed to divide the 170 by 50 by 50 by 50 kg to give you. So in this grade of concrete, you need a almost 3.5, a 3.5 bags to mix this concrete. Then we'll go to the sand. The dry ratio of the sand is still remains the dry ratio. That is the dry volume of the sand remains the same. Then what is the part for the sand in the 13 part is 4. So 4 divided by 13 gives you 0.3, 0.31. 0.31. Now you multiply it by your dry volume. It gives you 0.474 meter cube. You now want to convert it to ton. You have to now multiply by the density of sand, which is 1.45. This varies. So it is always advisable that wherever the source of your sharp sand will be, you fetch it, you take it to the lab, it is tried, you now know what the density of the sand you are using is. So that can replace the 1.4, which is the one that falls between. It tells you hear in some literature, you're told that it ranges from 1.45 to 6 to 1.6. So this will surely be determined from where you're getting your materials and being taken to lab. Then that is where you can now actually know what is the weight, the density of that particular sand you're going to use. So if you now multiply by density, you have 0.68, which is what you're seeing here. You're seeing here 0.69 approximately. Then for the granite, the same thing. It is 8 out of the 13 part. You divide it by 13, you have 0.62. Then you multiply it by this, you have 0.95 cubic meter cube. You now multiply it by the density. Granite as well differs too. If you're using a igneous rock, you're using a sedimentary rock, their weights are not the same. So that has to be taken to lab too, to now determine what the density of those rocks are, so that that can replace this and all of that. So by the time you multiply it by the cubic meter by the density, you have 1.421, and that is what is here. So after getting all of your material that you needed, you now, mind you, this cannot be complete without water, and water falls in the preliminary, fall within the preliminary items, the indirect cost. If you're sinking a borehole, If sometimes in your preliminary say water for works, so you calculate what the volume of water you want to use for the work, and you put a particular sum there, which now account for the water you are going to use throughout the duration of the project. So you can see that these rates are coming from my basic rates, and my basic rates are here, where the granite you see here is the going price for granite per ton is 8,000. 8,000 multiplied by 20 ton. If you're using a 20-ton truck to deliver it to site, then you have plus 80,000, which is the cost of your transportation to site. Mind us, this price differs from one political zone to another. You take, for instance, you're supposed to do a project in Lagos. You know that for you to get granite, for you to execute a job in Lagos, you have to go as far as Ibadan to get these materials. So you can see that the cost for transporting the material sometimes is even more expensive than the granite itself in such location. Places, there are selected places in the south, the south, and all of that, that you hardly get granite. So this will always uh, differ from one location to another. Then so that this amount divided by 20 gives me cost, the transport cost and the cost of material divided by 20 give me the cost per ton as 12,000. So you can see I have my cost per this is granite without transport is 8,000. Then granite without this is the transport. Sorry, this is 80,000. This is so the transportation is 4,000 per ton. If you sum it together, you're having 12,000. Then the sharp sand is 230,000 for a 30-ton container truck, a container truck, which is usually referred as is it 12 tires, 12 tires truck. So if you have, this is the cost. So now, and your cement per bag is 9,500 divided by 50 kg in a bag gives you 190 naira per kg. You go back to your basic rate. These are the rates already linked to my basic rate, meaning that once I have this in place, and mind you, the yellow spots are the only areas I can modify if I am given a different grade of concrete. If I'm given a different grade of concrete, the only place I'll modify is just the yellow spot. That is why it's been highlighted. And I modify this area, then I go to my basic rate. What is the prevalent? Change the prevalent the rate to the current rate. Then as soon as I change those areas, the yellow spot and this area, my unit rate will be current. As you can see, I have the cost for material as 57,473 naira per cubic. Then the labor cost, it can be determined in various ways. Either you're keeping your cost data from site over time, then you can now divide the volume of concrete you have done by the total amount you have paid the labor for the concrete to tell you what the average cost for a cubic meter will be. Or if it is in locations where you are using manual mix, where the laborers in that area will tell you they are mixing per bag. Say if they are mixing a bag for say a thousand 1,000 naira or 1,500 naira. So if it is a blinding concrete, which is just a 3.5 bag, you multiply the 1,000 by 3.5 bag, tells you what the the rate, the amount you're going to put for that particular grade of concrete. If it's a 6 bags grade of concrete, you multiply the 1,000 by 6, gives you 6,000. Then if you don't want to go in that one, you want to have an average, which will be applicable to all the concrete. I did a simulation here. Say I have a, a suspended slab I want to cast, and I have asked the people we call organizers, those that are people that will bring in the labor, that the labor contractors, they bring in the labor for a particular work. You pay the labor and you pay them for their own effort. You pay them for their own. You pay them for their own effort. Then see, so if you bring them and you pay them for their own effort, so over time, you've been able to determine the number of workers they bring for a certain a certain uh, a certain kind of concrete work. Say you have a beam, a monolithic slab you want to cast, where you are casting the slab and the beam at the same time, and say the volume of that slab is say 25 cubic, and 25 cubic, and since it's a structural concrete, the minimal cement requirement is not less than 6. So by the time you multiply the 25 by 6 cubic meter, 6 bags, it will give you say 150 bags is what they are going to exhaust for the day. So now, and this is the cost for the 21 laborers that are going to come to do the job. And this is the cost for the 2 machines that are going to arrange the surface of the concrete to make it look nice and level. Then the organizers that brought them, we're going to pay him a certain amount of money, say 15,000. Then the total is 140. Divide by 25 gives you 560,000, 5,600 per cubic meter. Mind you, this has nothing to do with the plant. The plant falls under preliminary item, so that has to be computed differently, because if you want to you're executing such kind of job, you're bringing in people, you have to kit them with PPE. If you have engineering staff, you have to provide accommodation for them. The cost of the salaries for the engineering staff, the salary of, if it has a project manager, the salary of the project manager, the salary of the cost of the mixer operator, the cost of the mixer. If there's a gas oil mixer, you have to provide fuel. If it is an electrical mixer, you have to provide a generator that will run it. You have to provide security that will uh, will protect the site during the day and night. You have to provide a temporal fence, either to protect where you have your sensitive materials and all of that. So that you have to build that rate separately. Then say you have a 5,000 cubic meter of concrete to do. You divide that amount by the 5,000, cubic meter. It gives you a certain amount that you now say you now put you now add to the cost of your material and labor for the concrete. Say you have a 5,000 for your indirect cost. So for this grade of concrete, which is the 1:4:8, you have a 68,000, including the assumed preliminary cost per cubic meter. Then by the time you factor in your overhead and your profit, which this also determine on the size of your establishment, that will also varies. So if say it's a 20% of the 68 gives you 13,000, the profit is 5,000, you add them together, you have 87,000 for the cubic meter of this grade of concrete. So also it is applicable to the other grades of concrete, this aspect you have 10 part as against the 13 part you have here, because 1:3:6. Then you divide the first part of for cement by 10. You have this ratio, and in this grade of cement 1:3:6, you have 221 kg. So I just rather than put 200, let me just pick the 221 kg at the point, then at once. So I have 221 kg of cement for this grade of concrete. You have your granite as 1.39. You have your sand at 0.667 ton. These are your rates, which are all linked from the basic rates. For this grade of concrete, you have 103,000 per cubic meter. Then for the grade of 1:2:4, you have 127 per cubic meter. Mind us, I said the indirect is an assumed amount because we're just assuming that we have a project, and I've been able to calculate all the provision I needed to make: the canteen, the staff toilet, the staff bathing room after close of work, and all of that. So you have to factor all of that into it. And if you've not been my followers, you're watching me for the very first time, you can visit my page, www.youtube.com/under quantity surveying made easy _2014. You see a lot of videos on how to build up your preliminary items, starting from personnel, equipment, safety materials, both collective safety and individual safety. You see also for temporary works, installation of temporary works like the canteen, the kitchen, the footing bases for cranes, and all of that. So that you can study on how to build up your preliminary items in that from those videos, and now you now know what I am talking about. The 5,000 I'm just putting here just for the sake of this exercise. So for the 1:2:4, you have 127,000. Then for 1:2:3.5, you have 133,000. Then 1:2:3, which is 370 kg, you have 140,000 as per cubic meter. So just like I did said, for each of the ratio, or each of the ratio, the only thing that changes is the parts, because like in this case you have 6 parts, and out of the 6 parts, 1 part for cement, 2 parts for sand, and 3 parts for granite. You know, the volume of materials will definitely increase because the lesser the part, the more the volume of cement in the granite, in the concrete. So please, if the video have been so helpful and has enlightened you on how to build up your rates, please share, like, most importantly, please follow me by subscribing. That is the only areas that will serve as an encouragement for me to continue to do what I am doing, and helping the profession grow. Thank you for watching. Bye for now.